Oh no, this is our main source for our village.
Hey, behave, bro.
Sorry. I know what happened. I think that is because of that factory. Okay, let's find out. Denishi!
Hey, what do you want?
I know you are the behind of this.
What? How can you do that? I'm the person that pollute the river using HNO3, you know?
What is pH? pH is a convenient measure of the acidity or alkalinity of an aqueous solution at a specified temperature, usually 20 degrees Celsius or 25 degrees Celsius. It measured on a continuous scale from 0 to 14. In the chemical laboratory, pH is commonly measured using an electronic pH meter, where the pH of aqueous solutions may determine to about 0.01 pH of unit if appropriate care is taken. How to determine the pH of the water? Firstly is visual method. Visual methods are completed with visual indicators such as pH test strips. Secondly is a photometric method. Photometric method determination involves shining a light through the sample and measuring the observance. Both methods rely on color of specific organic pigments in order to determine pH. However, it is not preferable because the measurement will be unreliable if the solution to be measured is cloudy or has an inherent color. However, lastly is the potentiometric method. Determine pH by using the electrical potential of pH-sensitive electrodes as a measurement signal, which is then displayed by a pH method. The method is very sensitive, so it be the sensitive method.
So, what is HNO3? It is a corrosive acid. It is a colorless liquid. Its molecular weight of HNO3 is 63.012 gram per mole. HNO3 is used in the manufacture of inorganic and organic nitrates and nitro compounds for fertilizers. HNO3 also will reduce the pH of the river. So now, we need to know how to produce HNO3. Firstly, HNO3 is commonly manufactured by Oswald process. First step of producing HNO3 is oxidized to form nitric oxide and also nitrogen dioxide. It involves two stages of oxidation. Second step, the nitrogen dioxide that was formed is absorbed in water. This will form nitric acid.
River life. The optimum pH for river water is around 7.40, but actually the range of optimum pH river is between 6.90 and 8.00. pH about 6.90 is only sufficient basic for bacteria, carp suckers, catfish, and some insects. So, the pH of the river in this scenario is 5.80. It is the pH for acidic range. Thus, let's think together. What makes the river become acidity? Water acidity can be increased by acid rain. Acid in pH can make a river inhospitable to life. Low pH is especially harmful to immature fish and insects. But in our scenario, HNO3 has been released from the plant, diffused into river and resulting acidic river when HNO3 ionized in water and producing H2O+ or hydrogen ion. To be clear, let's take a look at this equation. HNO3 react with H2O to produce NO3- and H3O+. So, the concentration of hydrogen ion or H3O+ increased. Thus, the river became acidic with lower pH value.
How to increase the production of acid nitrate, HNO3? The first factor is pressure. The main advantage of the high pressure is that it substantially reduces the size of equipment and piping required and hence leads to a reduced capital cost. The second factor is temperature. The temperature for this production of acid nitrate is most effective depends on the fuel. For hydrogen it is 450 Kelvin. For methane it is much higher, which is 750 Kelvin. The third factor is catalyst. The first catalyst is platinum and the second catalyst is rhodium. Rhodium is added to the platinum to give the Gauss strength and to reduce the loss of platinum. An important economic factor, 0.4 gram loss per 1000 kg nitric acid made. This is due to hot spots occurring on the Gauss. Recently, it has been found that GUAS increases the efficiency of conversion and prolongs the life of the catalyst. And the final factor is concentration. In the production of HNO3, the concentrated sulfuric acid is used to absorb the water content. Then on distillation of this mixture, concentrated nitric acid is obtained. The consequences to the aquatic life because of the acidity river. The first consequences is the bottom of the river was full with the undecayed substances and mosses that will compete with the aquatic life, which is fish to get an oxygen. And then the increment of acidity in the river can be the interference with fish reproductive cycle. Therefore, extreme pH can kill adult fish and the invertebrate, and also can damage the development of juvenile fish. And finally, the last consequence, calcium level in the female fish may be lower, and it can disturb the reproduction of eggs, whereby she cannot produce the eggs, or the eggs might be failed to pass from the ovaries, and if it fertilized, it will undergo an abnormal development.
How to prevent the river from being polluted? Okay, for the first one is treatment of waste before discharge. Factories are expected to treat its effluent waste prior to discharge. Second one is treatment plants. This plant filter out undissolved materials. Chemical treatment is also given to spread out unwanted dissolved chemicals. Third one is routine cleaning. Rivers should be routinely cleaned and treated so that it remains fit for human use. Treatment for the polluted river. Process, lime softening, also known as Clark process, type of water treatment used for water softening. Use the addition of lime water, calcium hydroxide to remove hardness, calcium and magnesium ions by precipitation. The process is also effective at removing a variety of microorganisms and dissolve organic matter by fluctuation. By filtering process, we can use neutralization method using filtering. For example is, the company can flow the river's water through the filter which contain alkaline such as magnesium oxide. This filtering method can neutralize the acidic water and increase the pH of the river back to its optimum pH.